Welcome to Section 5, Lesson 1, Video 1. Here we're going to be using an elimination strategy to solve a system of linear equations. So now when you're solving a system of equations using elimination, that involves eliminating a variable by either adding or subtracting the equations together. And in order for the variable to be eliminated, the coefficients need to be the same number, or at least they need to be opposites of each other. If they're the same, you're going to subtract the equations, and if they're opposites, you're going to add. So let's have a look at this system. If you look at the coefficients of x, they're the same number, they're both 2. So if I wanted to eliminate x from the system, I can just subtract these two equations, because 2x take away 2x is 0. Now for this system here, just look at the y terms. One has a coefficient of -3 and the other one has a coefficient of +3. So they're the same number, but opposites of each other. So if I wanted to eliminate y here, I should add these two equations together because -3 plus 3 is 0. So that's the basic idea behind elimination. You add or subtract the equations together as long as they have the same coefficient, and then a variable is gone. Now if they don't have the same coefficient, then you may need to multiply one or both of the equations by a number to ensure that the coefficients are indeed the same. And then once you have solved for one variable, then you can just substitute this into one of the given equations to determine the other variable. So let's have a look at example 1. We have to solve each system of equations using elimination. So you need to start by determining what variable you want to eliminate. So always look to see if the coefficients of a variable are already the same. Now if you look at x, I see one has a coefficient of 1 and one has a coefficient of -1. So we can just eliminate x easily by adding these two equations together. So now to do that, I'm going to start by writing out the first equation. And I'll write plus, and I'll write the second equation underneath. And then I'm going to add vertically. So when I add x plus -x together, that's going to be 0. So x is now eliminated. Now on to y. 3y plus -y is 2y. And then that's going to equal 5 plus 3, which is 8. Now to solve for y, I just need to divide both sides by 2, giving me a y value of 4. Now this is a step that's like substitution. To find x, you just need to replace y with 4 into the first or the second equation. So let's just say we plug it in right here. If we do that, we would have x plus 3 times 4 equals 5. Now 3 times 4 is 12. I'm going to bring the 12 over to the right-hand side now, giving me x equals 5 minus 12, which is -7. So now I can write my solution as -7, 4. Now just like when we looked at solving by graphing and substitution, you should always verify your solution. So let's go ahead and plug x to be -7 and y to be 4 into the first equation. If I do that, I would have -7 plus 3 times 4. Now simplifying that, I would have -7 plus 12, which equals 5. So that shows that equation 1 is verified. Now for the second equation, we have a -x, and x is -7. So you write it like this, -7 minus 4. Now that would equal just 7 minus 4, which equals 3. So we verified equation 2 as well. So the solution is indeed -7, 4. Now let's run through this process again for b. So what variable should we eliminate here? Well, I see that the coefficients of y are both 5, so that's the variable we should eliminate. Now, should we add or subtract these two equations together? Well, if I add them, 5y plus 5y gives me 10y, and we're looking for 0. So that means we should subtract, because 5y take away 5y is 0. So let's do that. So I have my first equation, subtract the second equation. Now 2x minus negative 3 is 5x. 5y take away 5y is 0. And 16 take away 1 is 15. So we have 5x equals 15. We can just divide both sides by 5 now, giving us that x equals 3. So now we can plug that into the second equation to give us negative 3 times 3 plus 5y equals 1. Now negative 3 times 3 is negative 9. I'm going to bring that over to the other side to become 1 plus 9, which is 10. Now let's divide both sides by 5, so we get a value of 2. So now we know our solution is 3, 2. So let's verify this. We'll plug these values into the first equation. So we have 3 times 2 is 6, and 5 times 2 is 10. And when I add 6 and 10 together, I get 16. So that is verified. For the second equation, negative 3 times 3 is negative 9. 5 times 2 is 10. And adding that together gives us 1. Now, it was also previously discussed that while it's always important to verify, if the question doesn't specify that, you don't always need to show your workings. You can just go ahead and do it in your head. So now we have example 2, where we still need to solve the system using elimination, but we're going to have to do an extra step here. So just look at the coefficients of x and y. Neither of them have the same coefficient, like we had in the previous examples. So what we're going to have to do here is multiply the first equation by 3 to make the coefficients of x the same. So let's go ahead and multiply the whole equation by 3. So if I do that, I would get 3x plus 12y equals 3. Now let me write the second equation right underneath it. Now since the coefficients of x are both 3, that means I'm going to have to subtract these two equations to eliminate x. So 3x take away 3x is cancelled. Now we have 12y take away 5y, which is 7y, and 3 take away 10 is negative 7. Dividing both sides by 7 now would give us a y value of negative 1. Now let's plug that into the first equation right here for y. So we have to work out x plus 4 times negative 1 equals 1. Simplifying that, I get x minus 4 equals 1. Now I'm just going to bring the negative 4 over to the other side, so I can add that with the 1, giving me that x is 5. So our solution is 5, negative 1. I'm not going to write out the steps for the verifying, but you can go ahead and do that if you like. Now take a look at this system for a moment. You notice that it's written a little bit differently than the other examples. Here, the x's and y's and constants are not lined up. So that's what we're going to start by doing. We're going to rearrange this equation so that we have x's over x's, y's over y's, and constants over constants. So I'm going to bring the 4y over to the left to make it 5x minus 4y equals 8, and then bring the 3x over to the left and put it in front of the 3y to give us the second equation here. So you can see now everything is lined up, and it looks like the previous systems we looked at. So now what variable do we want to eliminate? Neither x nor y have the same coefficients, so that means we're going to have to multiply the equations. So that's fine, but what will we multiply by? Well, let's say we want to get rid of x. What coefficient can we make both of these equal to? So you got to think, what can 5 and negative 3 divide into? It's kind of like finding an LCD, a lowest common denominator. So 5 and negative 3 can both divide into 15. So we can do that. We can make the coefficients of x 15. Or say you want to eliminate y. Well, what number can -4 and +3 divide into? They can both divide into 12, so you can make both of the coefficients 12 if you like. So you can choose to do either one. I'm going to make the coefficients of y 12. Now because I have one positive and one negative coefficient of y, I'm really going to make the top equation be -12y and the bottom equation be +12y. So now if I want to make the top equation -12y, I need to multiply the whole equation by 3 then. And if the bottom equation is going to be a +12y, I just need to multiply that one by 4. So now if I multiply the top equation by 3, I will get this. 15x minus 12y equals 24. And the bottom equation would be -12x plus 12y equals -12. So now let us add these two equations together so that the y's are eliminated. Now 15x plus -12x is 3x. The y's are going to cancel, and 24 plus -12 is 12. Now if I divide both sides by 3 now, I get an x value of 4. Let's plug that in right here to help us figure out what y is. So we have 3y equals 3 times 4 minus 3. Now 3 times 4 is 12. If I subtract 3 from that, I get 9. So if 3y equals 9, I'll divide by 3 to give us a y value of 3. So our solution here is 4, 3. And again, I'll leave it to you to verify this. So now you have another algebraic method of solving systems of linear equations. You can now move on to the next video in this lesson.